So today we will do the topic that is refraction of light. The name of the topic is refraction of light. Now, this is a CBSE ICSE combined class. For CBSE there is reflection of light. I have discussed reflection of light with you, and reflection of light with spherical mirrors I have already uploaded in my YouTube channel. Right or wrong? I have already uploaded in my YouTube channel the reflection of light with spherical mirrors, and it will be ongoing. Okay, continuously it will be uploaded. But in the meantime, I also want to start with refraction of light. Okay. Now, when I begin with refraction of light, let me compare it with reflection of light and then begin refraction of light. So, you see, in case of reflection of light, if I talk about reflection of light, what do we know? The phenomena of bouncing back of light when it falls on any surface, the incident ray and the reflected ray we see, and this phenomena of bouncing back of light when it falls on any surface, that is known as reflection of light. But what is refraction of light? The phenomena of bending of light. The phenomena of bending of light when it travels from one medium to another. The phenomena of bending of light when it travels from one particular medium to another particular medium. Now here medium means the optical medium. You see what the basic thing is, that in light I taught you is electromagnetic wave, did I in my previous videos? Yes or no? Tell me.
Yes.
You have understood light or perceived light as to be the electromagnetic wave, yes or not? Okay. Now when light is an electromagnetic wave, then what light is? Light is the vibration of electric fields and the magnetic fields. Light is the vibration of the electric field and the magnetic fields, where maybe the black ones are representing the electric field. The black ones are representing the electric field lines or vibrating electric field lines, and the blue ones are representing the magnetic field lines. Now, this is what light is. This is electromagnetic wave, and one part of electromagnetic wave is actually light. Now the fact is this, that the speed of this electromagnetic wave is affected by the speed of this electromagnetic wave is affected by the medium through which it is traveling. Although we know that for traveling of electromagnetic wave, we do not require any material medium. Like normal mechanical waves like sound wave and other waves, when we talk, or any other kinds of waves like ripples and all, when they travel, we do not require we do require the particles of the medium to vibrate so that they can travel. Sound travels by the vibration of the particles of the medium. Ripples travel by the vibration of the particles of the medium. And these all things I have taught you in the first two videos. Yes or no? You remember all these things I have taught you quite a few days back? Now the fact is this, that electromagnetic wave, although it is electromagnetic wave, although it is wave, But still, the fact is this, that it do not or it does not make the particles of the medium vibrate to propagate. What it does is, it actually vibrates the electric field and the magnetic field. Is this clear to you? So when it vibrates the electric field and the magnetic field, the electric field and the magnetic field vibrating perpendicular to each other spreads in a medium. This is the graphical representation. You must remember that I have told you that in a light source, the waves come out in this way. Do you remember this fact also from the first two videos? These are known as wave fronts. Do you remember this also? Huh? And to consider dual nature, you should understand that the light rays are always perpendicular to the wave fronts. Yes or no?
Yes, sir.
Do you remember that I have taught you these things? Now things are coming back to you.
Yes, sir.
Now it has certain speed with which it is going, right? Okay, so this does rings a little bit of bell in our mind that yeah, it was posted in YouTube and it was told to us that whatever is the shape of the source of the light, if the shape is like this, if it is a rod light, then the wave fronts will come out like this and the rays of light will be perpendicular to it, and that is how light is dual. But what I am trying to say is that although light is a part of the electromagnetic wave, but we can say that light is the visible part of the electromagnetic wave, visible part of EM wave or electromagnetic wave, although we can say that, I want to tell you that the speed of this electromagnetic wave, although doesn't, like for example sound or ripple, any kind of wave, when they travel through the medium, they make the particles of the medium vibrate to travel. Are you getting my? They make the particles of the medium vibrate to travel. But light wave or the visible part of the electromagnetic wave or whatever light wave, which is electric field and magnetic field perpendicularly vibrating to each other, doesn't require the particles to vibrate for its traveling or for its propagation. It doesn't require. But still, as because it is the vibration of the electric field and as because it is the vibration of the magnetic field, both electric field and magnetic field, their strengths depend on the medium through which it is traveling. I can clarify it in this way. Suppose, for example, a positive charge is there and it creates electric field around it. Now, if this is an oscillating positive charge, oscillating means moving positive charge, then it will create oscillating electric field. Are you getting my point? And also magnetic field. Now, the strength of these electric fields depends on a particular thing of the medium that is known as the electrical permittivity, epsilon naught, which we learn in class 12. Okay. And also the B vector that will be created in the electromagnetic field, the B vector that is created or the magnetic field that is created, what should be the strength of the magnetic field, that will depend on the magnetic permittivity. Two things, electric permittivity and magnetic permittivity. Now sir, what are these two things? We don't need to go into the details of these two things. What we just need to understand is, suppose two charges are kept. These two charges have forces of attraction in air. The same two charges will have forces of attraction in vacuum. The same two charges will have forces of attraction in water. The same two charges will have forces of attraction inside oil. But these forces will vary from one medium to another medium. Why they are varying? Because they are varying, because the permittivity of the electric field is different in different medium. In the same way, if there are two magnets, the force of attraction between the magnets will vary in different medium, because the permittivity will vary in different medium. In air, there will be one kind of permittivity or permission. Will be one kind of, in water the force will vary, in oil the force will vary, and the forces will keep on varying in different mediums. So these electric strength and magnetic strength, or electric field and magnetic field, when vibrates, and when they will start traveling through a particular medium, it may be so that it will not make the particles of the medium vibrate, but the medium itself will give a particular amount of permittivity to the electric field lines and magnetic field lines, that you have this much amount of strength in this medium. Oil will say that my permittivity is this much, electric permittivity is this much, magnetic permittivity is this much. So you have. Now in different mediums, when these electromagnetic wave will start traveling from air to water to oil to glass or any other optical medium where it has some optical density. Sir, optical density means, optical density is not the normal density that we talk about. That is why I explained all these things. Are you getting my point? Optical density is that how much it is allowing light to go faster or slower. And that depends on things like, on that particular medium, how much the medium is allowing the strength of the electric field and the magnetic field. And as I said, by the example of attraction in different mediums, that will vary in different mediums, because different mediums have different constants or different allowance or different permittivity. That I will allow this much, I will allow this much, I will allow this much. And when, suppose in water, the allowance is different than that of the air of two positive charges to repel. जो air में दो charges जितना जोर से repel करेगा, शायद water में उतना जोर से repel नहीं कर पा रहा है. क्यों? क्योंकि इलेक्ट्रिकल परमिटिविटी वैरी करता है. ठीक उसी तरह उन्हीं चार्जेस के इलेक्ट्रिक फील्ड, उन्हीं चार्जेस से पैदा हुए इलेक्ट्रिक फील्ड जब उससे वाइब्रेट करके जाने लगेंगे तो उनमें भी फर्क पड़ेगा. सेम चीज मैग्नेट के लिए भी है. मैग्नेट, दो मैग्नेट अगर एयर में जितना ज्यादा अट्रैक्ट या रिपेल कर पा रहा है, शायद वाटर में उतना ज्यादा अट्रैक्ट या रिपेल नहीं कर पा रहा है, क्योंकि उतना ज्यादा फोर्स नहीं हो पा रहा है, नहीं लग पा रहा है. और उसका रीजन क्या है? उसका रीजन है शायद द अलाउंस ऑफ द परमिटिविटी ऑफ द मैग्नेटिक परमिटिविटी इज डिफरेंट इन द डिफरेंट मीडियम्स. तो डिफरेंट मीडियम्स में उसी मैग्नेटिक फील्ड का स्ट्रेंथ जब वाइब्रेट करने लगेगा तो अलाउंस डिफरेंट हो जाएगा. इज दिस क्लियर और नॉट? Am I being able to easily reach out to you? Did you understand what I'm trying to say? You understood why is your mukh made like, cucumber? Your entire face became like a cucumber. You didn't understand. So what basically is, always remember the speed of light is epsilon naught divided by mu naught. I forgot, it should be ulta. Okay, so C is equals to epsilon naught by mu naught. Always remember this. So sir, that means in different medium, epsilon naught and mu naught will vary, because different medium will have different permittivity or allowance of the vibration of these electric and magnetic fields. Yes. So when they will travel from one medium to another medium, the C will change. Yes or no? Yes or no? The C will change or not? Yes, sir. Sir, never in any YouTube video, any teacher started refraction of light and told all these things. What the heck are you teaching? Mu naught, epsilon naught, C is equals to mu naught, epsilon naught. I don't care what the heck I am teaching. Are you understanding what the heck I am teaching? Did it enter inside your brain? That is what matters. Did it enter? Yes, So what is the conclusion of such a scientific discussion is that from one medium to another medium, one optical medium to another optical medium, the speed of light will vary and the optical density will vary. Means the mu naught and epsilon naught will not be same in water, air, oil, glass, diamond, etc. places, but mu naught and epsilon naught will keep on what? Varying. And hence the strength of the electric and magnetic field line vibrating each other, which is actually the light wave, the speed of the light wave will change, but not change. It will change from one medium to another medium. Is this clear to you? And it clearly says C is equals to epsilon mu naught by epsilon naught. The mu naught and epsilon naught for each of the medium, for water, for air, for glass, for everything is different. So speed of light in each of them will be different because the strength of this will be different. Yes or no?
Yes, sir.
Understood?
Yes, sir.
So this is the reason why speed of light is different in different optical mediums. This is the reason why we say that different mediums have different optical densities. So what two things we learned is that different mediums have different optical densities and speed of light varies or changes when it goes from one medium to another. So the reason and the reasoning of this entire understanding is clear to you or not clear?
Yes.
It's clear? So can I rub the board?
Yes.
Okay. Now, suppose, try to understand this very well. Okay. If you understand this, you will understand refraction in one go. Suppose there is separation of two optical mediums, maybe air and water. Now, according to the definition that speed of light changes and optical density, what we have just learned, air is optically rarer. Rarer means less denser. Water is optically denser. And the fact is this: if air is optically rarer, then C is equals to epsilon naught and mu divided by mu naught in air is higher, and C is equals to epsilon naught epsilon by mu in water is less. Means in air the epsilon naught and mu naught are varying. Means the magnetic field and epsilon and mu naught is constant. So the magnetic field and the electric field that are vibrating and the speed of the light that is coming, or the speed of the light wave that is coming, is something. But when it enters the water, the electrical permittivity and the magnetical permittivity has changed, and the ratio have changed, the C has changed. And what it has become, it has decreased. It has what become? It has decreased. It remains highest in vacuum or in air. Are you getting my point? It has decreased. So speed of light has also decreased. So what we learned? We learned that no need to go for so tough things. We learned that in optically rarer medium, speed of light, C, is high. And in optically denser medium, speed of light is less or low compared to the speed of light in the denser medium. Is this clear to you? Is this understood? Huh? Okay. So I hope that you have understood to this much. Now suppose this is a line which separates two medium. When you take a line when separates two medium of two different optical densities, we call it interface. We call it what? Interface. Do you understand the meaning of interface? Interface means the line which separates out what? Two different medium. Which separates out two different medium. What are these two different mediums? These two different mediums are air and water in this case. Now suppose from somewhere a source of light is there which is creating light waves. Now if you think that this source of light is goal or round, the light waves will be round and come and travel, and once it will hit the interface and try to enter inside the other medium, because the other medium is also transparent, maybe optically different denser, but it will try to go inside. But I want to change my drawing a little bit, because why? Let me put forward a logic. Suppose there is a very big circular field. If you take a small part of it, doesn't it look like a straight line? If there is a very big circular field, from the circumference, if you take a small part, it looks like a straight line, yes or no?
Yes, sir.
Yes, sir.
In the same way, here the wavefront that I will take, in the same way, from the light wave, the wavefront that I will take, which will come and strike the interface, in this way, I will take it to be a straight wavefront. This is what? A light wavefront. Didn't you learn that light creates wavefront like this? It will runs as wavefront. Yes or no?
Yes, sir.
This is light wave. How light wave is traveling? How electromagnetic wave is traveling? वो वाला डायग्राम तो सिर्फ ग्राफ है. ये वाला जो देखते हो ये तो ग्राफ है कि इलेक्ट्रिक फील्ड मैग्नेटिक फील्ड वाइब्रेट कर रहा है, लेकिन सच में तो ऐसे जा रहा है. ये तो सिखाया था ना उस वीडियोस में. सिखाया था कि नहीं सिखाया था?
Yes, sir.
Yes or no?
Yes, sir.
तो एक वेव फ्रंट आके एक गोल पार्ट का एक छोटा सा पार्ट ले लोगे गोल वेव फ्रंट का, तो स्ट्रेट ही दिखेगा. तो ये वेव फ्रंट आके ऐसे ऑब्लिकली हिट किया है. कैसे हिट किया है? ऐसे ऑब्लिकली हिट किया है. सर वेव फ्रंट तो ड्रॉ कर लिए, वेव फ्रंट के ऊपर रे कैसे ड्रॉ करते हैं? वेव फ्रंट के ऊपर रे हमेशा परपेंडिकुलरली ड्रॉ किया जाता है. यस और नो?
Yes, sir.
So this is the incident wave front. This is the incident ray. Is this clear to you? Is this understood? Now what will happen? See, from here to here, this portion of the wave front will start traveling. Will travel from here to here like this. And when it will travel, it will also travel, yes or no? Now the fact is this portion of the wavefront is already entering in the optically denser medium where the speed is decreasing. And this portion of the wavefront is already in the optically rarer medium where speed is still high.
Yes, sir.
Are you getting my point? So the time required to reach from here to here, by that time it will not be able to cover that much amount of distance. Yes or no?
Yes,
Am I right or wrong?
yes, sir.
Because this portion of the wavefront has more speed because it is still in the optically rarer medium, and this portion of the wavefront has less speed because it is in the optically denser medium. Am I right or am I right?
Yes, sir. Right.
So by the time it will reach here, at the same time it will not reach much far but here. Is this clear to you? Now remember, I also taught you that when light creates waves, it creates wave from one wavefront, उससे दूसरा wavefront बनता है, दूसरे wavefront से तीसरा wavefront बनता है, और ऐसे जाता है. सिखाया था कि नहीं सिखाया था? राइट और रॉन्ग? जैसे रिपल्स कैसे बनता है? एक डिस्टरबेंस से इस डिस्टरबेंस से दूसरा डिस्टरबेंस बनता है, दूसरे डिस्टरबेंस से तीसरा डिस्टरबेंस बनता है. ठीक उसी तरह यहाँ से सेकेंडरी वेवलेट्स बनते हैं, और सेकेंडरी वेवलेट्स बन के दूसरा, ये क्लास 12 में और अच्छे से पढ़ना, क्लास 10 के लिए खाली इतना जानो कि एक वेव फ्रंट है, उसी वेव फ्रंट के डिस्टर्बेंस से दूसरा बनता है, उसी के डिस्टर्बेंस से तीसरा बनता है. इज दिस क्लियर टू यू?
Yes, sir.
ये सिखाया था भी, सिखाया था कि नहीं सिखाया था? पिछले वीडियोस में देखो, बिगिनिंग लाइट इन डिफरेंट वे, पार्ट 1 पार्ट 2, राइट और रॉन्ग. अब क्या होगा, अब तुम यहां से जब यहां तक आ गया ये वेव फ्रंट, और यहां से जब यहां तक आ गया तो नया वेव फ्रंट यहां पे क्रिएट हो गया. इज दिस क्लियर टू यू? इज दिस अंडरस्टूड? अब नए वेव फ्रंट में ये पॉइंट ऑफ इंसिडेंस है, ये पॉइंट ऑफ इंसिडेंस है. पॉइंट ऑफ इंसिडेंस से अगर तुम नए वेव फ्रंट में ड्रॉ करने जाओगे, ये सोचो एक परपेंडिकुलर लाइन है जिसको हम लोग नॉर्मल कहते हैं. अब तुम यहां से परपेंडिकुलर ड्रॉ करने जाओगे, इस साइड में परपेंडिकुलर होगा कि ज्यादा इस साइड में होगा? कौन से साइड में परपेंडिकुलर ड्रॉ कर पाओगे? तुम जितना नॉर्मल के पास आओगे उतना परपेंडिकुलर ड्रॉ कर पाओगे. यस और नो?
Yes, sir.
So what has happened to the light ray? It has bent towards the normal. So when light ray travels from one rarer medium to denser medium, it bends towards the normal. Yes or no? Did you understand or did you not understand? Is this clear to you?
Yes, sir.
तुम इसी एक्सपेरिमेंट को यहाँ पे करके देखो. एक लाइट रे यहाँ पे ड्रॉ करो परपेंडिकुलरली, एक यहाँ पे ड्रॉ करो. यहाँ पे परपेंडिकुलर ड्रॉ करने के लिए तुमको ऐसे करना पड़ेगा. देखो टुवर्ड्स द नॉर्मल बेंड कर. यहाँ पे करके देखो, एक लाइट रे परपेंडिकुलरली ऐसे ड्रॉ करो, और यहाँ पे एक नॉर्मल ड्रॉ करो. देखो टुवर्ड्स द नॉर्मल बेंड कर रहा है कि नहीं कर रहा है? इज दिस करेक्ट और नॉट? किसी भी पॉइंट से करके देखो. एक लाइट रे ऐसे आया, अब परपेंडिकुलर ड्रॉ करने के लिए इस साइड में थोड़ी ना जा सकोगे, इधर ही करना पड़ेगा. तो क्या कर रहा है? टुवर्ड्स द नॉर्मल. और क्योंकि लाइट रे हमेशा क्या होगा? परपेंडिकुलर टू द वेव फ्रंट होगा. ये सन नो?
Yes, sir.
आया बात समझ में कि नहीं आया?
Yes, sir.
So why it bends towards the normal, you understood?
Yes, sir.
हाँ, why light bends towards the normal, you understood? स्कूल में क्या किया होगा? स्कूल में बताया होगा बच्चों, मित्रों, क्या होता है? होता है डेंसर मीडियम और रेयरर मीडियम, सॉरी रेयरर मीडियम और डेंसर मीडियम. लाइट रे आता है, टुवर्ड्स द नॉर्मल बेंड होता है, एंड इसको रिफ्रैक्शन कहते हैं. हो गया होगा चैप्टर कंप्लीट. इसलिए तो 2 दिन में होता है. और तुम लोग भी अजीब पागल हो, ना कोई रीजन दिमाग में आता है, ना पूछने का मन होता है सर क्यों होता है. अब बताओ, कोई क्वेश्चन है दिमाग में? कोई क्यों, व्हाई, एनी व्हाई इज देयर इन योर माइंड? आई हैव किल्ड ऑल द व्हाईज. नो व्हाई. डू यू हैव एनी व्हाई क्वेश्चन? Why light bends, how light bends, everything you know. But that is very wrong. You don't know everything yet. You will learn more details of it in higher classes. I'm just making things more presentable in front of you. I hope you liked it. What happens when the opposite thing happens? Let us try to understand that. Opposite thing happens means when light travels from rarer medium to denser medium, that means when it becomes, denser medium to rarer medium, when it becomes faster. At that time what happens? Let's see. अच्छा सर, कोई बोलेगा ये YouTube वीडियो देख के, ये कोई मेरे पढ़ाने का स्टाइल अभी मैं ओपन कर रहा हूँ, लोगों को दिखा रहा हूँ कि देखो ऐसे पढ़ाता हूँ, तो कोई निंदा करेगा. ये सब तो जरूरत नहीं है, क्यों बता रहा है ये सब? इस क्वेश्चन का आंसर मैं इसी वीडियो में दूंगा. ये सब अगर जरूरत नहीं है, ठीक है, तो बिना ये सब समझाए मुझे एक बात समझाना पड़ेगा. और वो एक बात क्या है, वो सस्पेंस है, मैं बताऊं. ठीक है, पहले देख लेते हैं कि उल्टा होने से कैसे ड्रॉ करेंगे. ओके, नाउ लेट अस ट्राई टू अंडरस्टैंड दैट इफ देयर इज एन इंटरफेस and if there is light ray which comes and strikes obliquely, let it split up. let it make it like this. Okay. If a light ray comes and strikes obliquely, light ray or light wave, right or wrong, comes and strikes obliquely. Suppose this is water and suppose this is air, right? Means from denser medium to rarer medium now. So speed will increase. Now by the time it will reach here, speed has increased, it will reach somewhere here, yes or no?
Yes, sir.
This is obvious. So the new wavelet that has been created will be, a new wavefront will be like this, yes or no? Understood? Now let us see what has happened to the light rays. Light ray will draw what? Perpendicular? Yeah?
Yes, sir.
This is the point of incidence. This is the incident ray. Now if I have to draw a perpendicular to the second wave or the second wave front, where should I go? This side or that side?
That side.
Sir, away from the normal.
Okay. Away from. So this is what happens when speed increases. So overall what we learn? From the previous picture and from this picture, over we learn that when light travels from one medium to another, if the optical densities of these two mediums are different, then the speed of light will change, due to which light will bend from its straight path, and this phenomena is known as refraction. Am I right or am I right?
Yes, sir.
You are right.
Is this definition correct?
Yes, sir.
Is this definition understandable? Do you need to learn this definition?
Yes.
No.
Right.
It is easy? Okay, now listen to me. When light travels from rarer to denser, then velocity of light decreases or increases? Tell me. Decreases. So when velocity of light decreases, light bends towards the normal, which we learned in the previous video, previous section of the video. Right or wrong? Let me draw it in short. Come on. Yeah, it bends towards the normal. Right or wrong? It's proved. Yes? When light travels from rarer medium to denser medium, because the speed decreases, and this is the proof that speed decreases. एखाने बेशी चले आसছে, यहाँ पे ज़्यादा चला आया है, और यहाँ पे कम आया है. जितना टाइम में ये travel कर पाए, में speed ज़्यादा है यहाँ पे. और this is the proof that it is faster here. It is traveling from denser medium to rarer medium, क्योंकि यहाँ पे speed क्या हो गया है? बढ़ गया है. Right or wrong? So when light travels from denser to rarer medium, ulta. When light travels from denser to rarer medium, velocity of light will, tell me what, increases or decreases? Increases. And light bends towards the normal or away from the normal?
Away.
Away from the normal. अब एक बात बताओ, ऐसे पढ़ने में अगर किसी को मजा नहीं आया होगा तो उसको कैसे पढ़ने में मजा आता है मुझे पता है, और उन लोगों को मैं गधा कहता हूं। बता दूं गधों को कैसे मजा आएगा? अगर मैं ये पूरा वीडियो पहले से ऐसा बनाता तो गधों को बहुत अच्छा लगता, उस चैनल में 1.5 मिलियन लाइक्स हो जाता। कैसा? देखो बच्चों, ये रेयर मीडियम है, ये डेंसर मीडियम है। रेयर मीडियम मतलब डेंसिटी कम, मतलब लाइट जल्दी जल्दी भागेगा। जैसे खुले रास्ता में बाइक लेके आप जल्दी जल्दी जाते हो तो लाइट जल्दी जल्दी भागेगा, और यहाँ पॉइंट ऑफ इंसिडेंस में एक नॉर्मल ड्रॉ कर लेना। और डेंसर मीडियम में क्या हो गया है, भीड़ भाड़ ज्यादा हो गया है तो बाइक स्लो करना पड़ेगा। तब स्लो करना पड़ेगा तो क्या हुआ, तुम सिकुड़ गए हो, तुम कोने में चले गए हो। अब क्या होगा, टुवर्ड्स द नॉर्मल बेंड किया। और ठीक इसका उल्टा सोच लेना बेटा, डेंसर टू रेयर अगर जाएगा, तुम सिकुड़ के जा रहे थे कोने कोने से, अचानक से तुमको हाईवे मिला और तुम फैल के जा रहे हो, अवे फ्रॉम द नॉर्मल बेंड कर रहे हो। क्या मस्त एक्सप्लेनेशन है, पूरा समझ में आ गया, याद भी रहता है ना? अगर कोई गधा मेरे क्लास में भी बैठा है वो ऐसे याद रखना, क्या है, कोई प्रॉब्लम नहीं। फिर भी डेफिनेशन तो यही रहेगा, फिर भी यही ट्रुथ रहेगा जो मैंने लिखा है। Is this understood?
Yes, sir.
So this is the video called Basic of Refraction. I will name this video Basic of Refraction. You understood refraction?
Yes.
Then we will understand laws of reflection, where refraction is occurring, how refraction is occurring, what are the laws and this and that and that and this. Is this clear to you?
Yes.
You like the class? You like the video?
Yes.
Thank you. Subscribe my channel. I hate to say that, but I need subscribers because I'm Garib.